You are listening to me as it should. Let me just cancel some. Oh, there we go. Um, cool. Awesome. Get rid of the overlay. There we go. That's me. Hello. Um, Starting in 5 minutes. Nah, start. Cool. Hello, hello. If you could please um here basically there we go. There's a link for you to check in. Hey, Karime. Cool. Awesome. I hope my internet is stable. Let's see. Yeah, should be stable. Cool. Awesome. So, hey. Nice. If you saw my earlier stream today, I'm going to ask yourself, like, looks different, right? Like this setup's just kind of weird. I'm at grandpa and grandma. It's September 15th here in Mexico, so pretty big deal. But yeah, hope everything's good. The bad thing is, if it rains, just a teeny tiny drop, it's like, ooh, internet's out. I hope that doesn't happen. Cool. Statistics with Matlab. I don't know if you've faced or been with Matlab before. I have. I'm a robotics and telecommunications engineer, which means I do a lot of Matlab. I work at MLH as a pod leader and a streamer, and I'm also working at a startup in Australia as a robotics engineer. That's really cool. So let me share with you some of my MATLAB knowledge and statistics knowledge. My iPad's just right here, so let's dive into that. So first, let's just take a look at statistics with MATLAB, okay? So let me see what happens if I do this, because I just have one screen. So can I split screen? Is that good? Oh, let's see. Does that work? I hope it works. Yeah, I think it works. Okay, cool. So statistics with MATLAB. So first of all, why would I use statistics? Like, you're a regular person, probably an engineer, probably not an engineer. Why? Just like, why? Well, statistics is everywhere. You can find it in the Weather Channel, for example. You're going to, I don't know, on a hike, and you see that it has a 50% probability of rain. I would think about it twice, because maybe you'll get some rain. If it says, hey, the probability of raining is 25%, you go like, yeah, maybe I'll go in, I don't know, I'll go hiking, or I can go fishing, I don't know, whatever. What about money? Like, hey, I read an article that says it's most likely that, I don't know, Google stocks go down next week. So hey, I probably might buy some other stocks or sell my Google stocks before that happens. I don't know, just be careful with stocks. But yeah, something like that. Or you could say, hey, I don't know, I'm using Waze, I'm using Google Maps. I might encounter 50% traffic in the upcoming 5 minutes. So I might just take another route. So it's up to you. It's up to you. Statistics are everywhere, and you just need to accept and kind of love the fact that they're everywhere, and just have fun with them. Cool. Now, why MATLAB? Like, why actually here I have to. Why MATLAB? Cool. So can I slideshow this? Last time I couldn't. Oh, cool. I can. Okay. So why MATLAB? MATLAB is a very powerful and versatile tool for analyzing, visualizing, and modeling data. Okay, it means that it's a great calculator. That's what it is. It's a calculator that's great for analyzing. So you can analyze data. That's what we're going to do. You can visualize your data, images, plot a lot of different categories such as scatters, banners, stuff like that. You can model data. You can create data sets easily with MATLAB. Okay, MATLAB uses its own programming language, but it's based in Java. Okay, so MATLAB is purely based on Java. That's how it is. Okay, Cool. It combines easy-to-use programming environment, built-in functions for statistics, probability, and machine learning. Okay, so it has its own tools, its own toolbox. It has its own libraries for you to import and use. Okay, allowing users to quickly explore and understand datasets. Okay, easy as that. Okay, cool. Now, this is an example of how Matlab works. Okay, so I'm a robotics engineer. This is something that I've done, not this specific chart, but something like that brings back old memories from classes. And if you ask yourself, hey, did you ace that class? I surely did. It was a 10 out of 10. It costs probably, I don't know, 2-3 nights of study each exam. Hey, it was worth it. But yeah, this is what Matlab can do. You can simulate robots, and you can have it's called the matrix of movement, where it tells you, hey, it can move either here or here, but here you encounter an entropy, so you can go here. Yeah, designing robots is not that easy, but it's kind of fun. You know, I'm a robotics engineer for a reason. If I were to do this again, yeah, I would probably, I don't know, buy a lot of monsters and not sleep, basically. But cool, that's what Matlab can do. Okay, let's jump into Matlab real quick. Okay, so I'll do maybe this. Okay, and now I'm going to present something else. Not having my two monitors, not liking it, but that's what we have to do when we're at grandma's. Okay, cool. Can y'all see this? I hope you can see it. Can you see it? Nope. Yes, that's Matlab. Okay, that's my cheat sheet. Okay, so let's say that we don't have a cheat sheet. Okay, this is how Matlab looks like. Okay, what happens if I do this and then Matlab goes here? Doesn't look good. Let's see if I can do this. Does that look better? What if I create a new? Okay, I think that's look good. Yeah, cool. Okay, nice. So this is Matlab. Okay, let's just get rid of untitled. Cool. Okay, we have a few buttons here. Simulink is a very, very powerful tool. Really cool to use, especially for control systems. We won't be using Simulink today. It's not topic, but you can use it. It's really cool. Okay. There are two types of scripts. Like the usual script, your code script, okay, that you run. You can type stuff here like CLC or clear, or I don't know, A equals 1 and B equals 2, okay, and run it, and voila, okay. But it doesn't show anything. The bad thing about the scripts is that if you're working interactively with them, it's boring. You have to run it each time. It doesn't show you everything. It's more for like backend functions. And if you're doing homework, I used to do my homework with live scripts. It just makes it better, especially for teachers, for them to grade. Okay, let's go with live scripts. Okay, get rid of untitled. No, cool, live script. So you can see there's a small difference in this one. We have a division, and in this division, we can do A equals 1. Run it. Ooh, well, that's interesting. We get A equals 1 here. Okay, so for example, if we do semicolon and then A equals 1. See, for example, what about A plus 1? 2. What about A plus 3? 4. Okay, so we can plot, print, we can do lots of things live. That's why it's called a live script. Okay, that's really cool. Now, careful, because when you run a cell, okay, to divide cells, you have to add text. Oh, my bad. Let's do enter and then text. You can type hello, okay, and then enter and then a new chunk of code. If you say, hey, I want to run A equals -1, and let's do A plus 3 as above, okay? So I'd say, hey, I run this cell. This should output 4, and A should stay as 4, or A should stay as 1 the entire time. Not quite. See? If I rewrite A in the following chunk of code, The bad thing is it gets rewritten, okay? Because everything runs at the same time. This one runs, and then this one, and then the following codes, okay? To avoid that, we have something called the section, okay? So there are two ways of doing sections. What I do is some lines and enter. See, now we have like if you can see this line, there's like a section break. That's how it's called. So we can do my bad. A equals 1, A plus 3. And then we have 4. See, but we didn't run this. I can actually get rid of, for example, this one. Run from here. Answer is 2, and then answer is 4. Okay, this means whenever I section break, I can use the same variables, but this chunk of code here, or this section here, will run independently from this one. Okay, so those are independent chunks of code called sections. Okay, it's not like a Jupyter notebook that you run each cell separately. No, sadly, yeah, I would say sadly, because it makes it easier, but sadly, no, it doesn't work that way. Mineral water, I don't like it. Sparkling water, that's how we call it. I don't know, I don't know. My grandpa has a lot of sparkling water, and I was like, yeah, sure, why not? Cool. Okay, so far so good. So live scripts, sections, cool. Okay, you can write in the text somewhat like markdown. Okay, so for example, you can do here you have your types of headings. For example, hello, my name is Chapelle, but people call me Bully. And happy face. Ooh. And happy face. There we go. And I can write text here like, this is a great formatting. See, now that's good. Okay, that's good because whenever you're doing either a project, homework, or something, it's just visually appealing. Everything that you do has to be visually appealing. Why? Because when you go back to it and you see it and it doesn't look good, your brain just shuts off. It says, hey, I don't like this. I hate it. Okay? So you can add text. Of course, you can add bullets, numbering. You can do italic. For example, this should be italic, for example. You can do lots of things with the Matlab Live. Okay, cool. Now, we have two interesting commands. We're not going to use them today, but I just want you to know, if you go to command window, you have like a terminal-ish. Okay, so for example, if I do A is kept, okay? A equals -1. Now, I don't like keeping A as -1. I want to get rid of everything. To do that, I do clear all. There we go. If I type A, it says, hey, what's A? I don't understand what A is because I just cleared the whole thing. Now, why is this important? Because if you're working with lots of different variables and you start having, let's say, like a leakage of variable values, then you do clear all and you just get rid of those variable values, okay? And you can restart. Because sometimes you get rid of all of them, but you're missing one and you didn't rewrite it and then you're using it and it's wrong. So you do clear all and that gets rid of all of the cache inside of Matlab, okay? You can see it here. I have to rerun this. For example, A equals 1. By the way, you run with Control Enter. You go with to command window, type A. Now you have 1. Okay, cool. To clear the terminal, you do CLC, and that's it. Or Control Enter. I think it works too. Or I think it's Control L. Let's do hello. Control L. Oh, it doesn't work. Okay, so CLC is the go-to. Okay, cool. Not going to use the terminal today, but yeah, the workspace is the one that carries the variables. Okay, see, we have A equals 1 and answer equals 4. Cool. So far, so good. Nice. Okay, let's just get rid of all of this and start working. Okay, cool. So before that, no, it's fine. It's fine. I think we can do it. Cool. So let's start with some basic commands before we go into statistics with Matlab, okay? This percentage here is for comments. Okay, my bad. I forgot the word comments. So if I want to comment, for example, hello. Yep, that's a comment. It's in green usually. I think you can tweak the colors. I just leave it as it is. Okay. Cool. Now let's do a equals 10 semicolon. Why the semicolon? It's not an error if you do it, but it just prints it by itself. If you don't want it to print, semicolon doesn't print anything. Okay. Cool. Let's do b equals -20. Yep. You don't have to declare the variable types. It's like Python. That's the way. Okay, cool. Now, what happens a plus b? What happens if I do this? And what happens if I do a minus b times a? Okay, this is important. Let's check this out. Cool. So a plus b is 10 plus -20. It's -10, easy peasy. But what happens here? A minus b, so it's 10 minus 20. It's 30, right? Times 10, it's 310. But something we have to remember something really important, and that's something that Matlab does by its own. It gives priority to mathematical laws. It means first we go into multiplication and then subtraction, okay? Which means minus b, which is -20, times 10 is -200. I'm sorry, -20 times minus is 20 times 10, it's 200, plus 10 is 210. See, no need for parentheses. Okay, that's why Matlab is a calculator more than a programming language. Okay, in Python, it doesn't happen. You have to do parentheses because sometimes Python just doesn't care about math. Cool. Okay, and you can do also a over b like this. Okay, so you can see it outputs a float even if it's not like it's a division of integers. Okay, you don't have to specifically tell Matlab to output a different type. Okay, cool, nice. Okay, so let's do something more important. Okay, cool. I'm not sectioning. Okay, I'm just just for visual. There we go. That's visually, that's good. Cool. Okay, so we can do interesting things. So we can create arrays without actually writing the whole array. Okay, so let's do data equals square brackets. It's like a list in Python. I want numbers from 0 all the way to 100. Okay, let's check it out. Okay, it takes time. There we go. So 0, 1, 2, 3, 4, all the way up to 101. Okay, these are actually 100. There we go. Okay, number 100. Okay, 101 because we were counting 0. Okay, careful, careful. I forgot to mention this. Matlab's way of indexing starts in 1, not 0. Okay, careful there, because if you're used to programming languages, you know that it starts with 0 always. Matlab just didn't care, and they were like, yeah, let's just start with 1 because why not? Just careful there, okay? Because you'll see a lot of indexing in 1. It doesn't mean it's the second one, it's the first one, okay? Just in this case. Cool. Now, let's just call semicolon this, because if not, then we'll have the output all the time. We can get the mean very easy. Mean, data, okay? We can do the same for the sum of data, okay? Actually, let's prettify this. Can get the mean of data. We can get the sum of data. There we go. And we can get the minimum, maximum, okay? Easy peasy. Max, data, min, data. 3 to 1, and let's see how it looks. Oh, cool. So the mean from 0 to 100 is 50. Okay, basically the middle, or it's not the middle, it's summing on the numbers over like the amount of numbers, and that's it, okay? Sum of data, it means we want to sum this. It's 5,000 or 50-50, basically 5,050. Okay, minimum and maximum 100 and 0. Okay, so far so good. That's interesting. Yes, hey Tammy, welcome back. Cool, awesome. So interesting. So I can't see. There we go. I think that's better. Cool. Okay. So let's start with some data science and then just transition into a little bit of statistics. Okay, cool. We have to have a data set. Okay, let me just find the data set. It's here. Double click on this. You'll be able to see it, but I'll share the link. It's this one. Okay, this is the first one. We're going to use, I think it's 3. Yeah, this is the first one. Okay, you can use it. It's from Kaggle. I love Kaggle. It has a lot of things. Careful with Kaggle because sometimes the things that people post are not accurate. So just be careful there. Okay. Cool. Nice. So let's not see that. Cool. Let's do a section break because I don't want things to just scramble. Okay. When you download a dataset, you have 2 ways. You can either do it from Matlab, which takes a lot of time because you have to download the API, and then it's not like with Python. What you can do is download the zip file that I have here, or the zip folder, and then unzip it. Okay, so in my case, this first part is from archive.zip. Okay, not 1, not 2, it's archive only. Okay, so that's why I'll do it. If you download it from Kaggle, it should be archive.zip. Okay, but if you have another name, just change it in the code. Cool. Okay. Nice. So unzip. That sounds weird. Oh, my bad. Cool. Unzip the data set. There we go. And then it's basically unzip. Should be archive dot zip. There we go. Let's semicolon it so we don't look at the whole output. Okay. Cool. Now we want to, let's see. I think I'm going to section here just because when I run this, I don't want it to unzip lots of times. Okay, so if I run it, I would get something that's called, I think it's scrub.csv. Let me just do it again and see what happens. Cool. Okay, so this one gives me complete.csv. Okay, let's look at it. If you double click, are you seeing this? I don't know if you're seeing this. No, you're not. Okay, if you double click, oh no, let's not double click. You can see it. Should I? Yeah, no. Let's leave it like that. You basically see the output in an Excel form, but we don't care about that. Okay, if you can double click on this, that's what you see. Okay, cool, nice. So now we unzip it, but it's not loaded in Matlab. Okay, it's just standing here waiting for us to work with. So let's just read the dataset and read the dataset. Okay, something that if you look online for the actual command, don't use, careful there, don't use read matrix. Okay, let's take a look at why not use read matrix. Okay, UFO dataset equals read table. Sorry, read matrix. That's the one that we are going to use, but you shouldn't. Okay, and then should be complete.csv. Okay, let's take a look at it. If we don't use the semicolon, again, it's going to output everything. It says not a number for everything. Don't panic, okay? Don't panic. Read matrix tries to read numbers. If you don't have a pure number dataset, it's going to say, I don't know what you're talking about. I'm sorry. I'm going to put everything as nan. No worries. Instead of read matrix, do read table. Okay, columns, blah, blah, blah. Ignore the warning. There we go. You can see here we have lots of things. Daytime, okay, city, state, country, shape, duration in seconds, duration, hours, minutes, and some comments. Okay, these are all UFO sightings. Okay, now there's something wrong with this dataset. var12. Okay, for some reason, we have this thing called var12, which is a column that has nothing. We have to get rid of it, because if not, it'll just be troublesome and we won't be able to do anything with it. Okay, so when you load data sets, when you're working with data from online, you have to clean it. Okay, it's like, I don't know, it's like buying a spoon. Okay, you don't use the spoon right away. You just clean it. If you do, then yeah, careful. I wouldn't do it. But that's the same thing. You wouldn't use data that you just found online. You have to double check the data too. Sometimes, and if you saw my, I think it was my first stream, it was on Friday. We had like I think it was a data set from the best movies or the IMDb movies and the ratings. It was horrible. Like the best movies were like movies that no one knew they existed, and they had budgets of like $210 million. Zero accurate. Okay, it was funny, but it was a way of me showing, hey, you have to be careful. Okay, cool. Now, let's get rid of that thingy. Let's just section this too, because if we run this one every single time, UFO dataset is going to be rewritten. Okay, so let's just separate it. Let's scroll down a bit here. Cool. Okay. We can do get rid of var12. Okay, easy. We can do it in a very easy way. Should I probably do this? Can I zoom in? Maybe, I don't know. I'm looking at the actual stream. Let me see. Is it all good? It looks good. I think it looks good. Yeah, it should. Okay. If you want me to zoom in, just let me know. Okay. Cool. You remember? Nice. The fact that it was like, what movie was it? I don't know. It was like a very random movie that no one knew it existed, and it was like score 100 in IMDb, and then it was like the budget was like 210 million, and I think the revenue was like in billions. I'm not sure. It was just weird. But yeah, check your data. Okay. Cool. Nice. So UFO dataset equals remove vars. Okay, because each column is represented or is read as variables. Okay, so we remove vars from UFO dataset. I want to get rid of var12. 12. There we go. Cool. Now let's run this again. Oh, my bad. I think it has to be single quotes in Matlab. Something that I'm not a big fan of, but yeah. Okay, you can see the last one is longitude. In this case, it was var12. Okay, cool, awesome. So nice. Let's section this one too, because if not, if we run it again, Matlab will go crazy and say, hey, I'm not sure if you're aware that var12 doesn't exist. Okay, cool. Can I get rid of minimize? Yeah, there we go. Cool. Awesome. So next thing that we can do is we have to clean the data further. So let's take a look at the data, and we have states and we have country, but things are missing. For example, country, states, another state here. We scroll down, we're missing 2 countries here, 1 state is just too much. Okay, you cannot work with something that's not a number. So either create a number for it, which is not accurate and get rid of your accuracy in the data set, or bye-bye, or just get a new data set. Okay, basically. Let's just go with option number 2. Okay, easy peasy. Cool, so in order to get rid of things, we have to see, or at least assume, that it doesn't, like, you're not losing like half of your data set just because you're missing values. Okay, so the way we do it is, let's count the things that are not a number or non-existent, and we compare it to, or let's kind of see how much it is if we either get rid of the whole data set and change it to a new one, or get rid of the emptiness, basically. Okay, cool. So let's see if we can afford to do it. Count the missing data. Okay, so you can, the way I wanted you to see it is if you do UFO dataset .city, for example. Let's run this one. Ooh. So every single column is a city. I'm sorry. Every single column is like a variable inside of the dataset. So you can access it in this way. Okay. We can access all of them saying UFO dataset dot properties with capital P dot variable names. Okay. Let's see it in action. Oh, there we go. Cool. See that? It's a 1 times 11 cell, and it's daytime, city, state, blah, 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 longitude. Okay? So far, so good. Cool. Now, let's just save that, okay? And let's save it in 2 variables, because if I don't save it in a variable, then it doesn't matter. Variable, there we go. That's it. And now let's count missing equals 0, okay? Cool. So we have a first count of missing, okay? Then we can do a for loop. For I equals 0, okay? Now, colon means all the way up to, okay? So from 0 all the way up to null, which is, I want you to number the amount of variables, okay? So far, so good. It's like this is basically doing in Python for I in range length variables. Okay, this is the same thing. Okay, cool. Nice. Get rid of this because it doesn't make sense for now. Nice. Now, semicolon. And why is there an error here? Oh, easy peasy. We can do end, and the error just goes away. Okay, cool. Now, we check if is numeric. We mean, hey, is the variable that we're looking at is a numeric variable? And the way we do it is numeric UFO dataset. There we go. And then in parentheses, variables in I. Okay. Then no need for colon here. Then missing missing equals missing plus the sum of is nan. It means I want you to check every column for every row of the column and check if something is not a number. That's why we're checking if it's nan. Okay, so we're not iterating through every row. We're going through every single variable name, which is each column. Okay, so if the first one is a number, then let's check, hey, let's check if it's nan, okay? And then we can do is nan, and inside UFO dataset, okay? Dot variables, oh, my bad. This one's inside of a parentheses, there we go. I'm not going to lie, this is not the friendliest scripting language. I know it's not. It's kind of Java. They wanted to do it like a Java Python thingy. I don't know. It could be better. Okay, cool. Else missing. So if it's not a number, it should be something else. Okay. In this case, we're expecting strings. So no worries. We can assume it is. Okay. I tested it, so let's just go with it. Okay. Cool. Missing equals missing plus sum of the same thing, UFO dataset. Okay, but instead of variables in I, instead of is nan, is nothing. Okay, cool, awesome. And we have to add an end here so Matlab doesn't go crazy. Okay, cool. What it does, let's just get back to it and read it again. We're checking, hey, for every variable, and every variable is what? Wait, what? This column doesn't go here. For every variable, which is every column, if that column is a numeric column, then I want you to say, hey, I am counting everything that is not a number, basically is missing, okay? If not, then I know it's a string, and I want you to count everything that is an empty string, basically. Okay, so far so good. Let's run this and see how it goes. We have to do missing here. Did I semicolon this? Yes, and this one no. I'll just semicolon this so we don't have a lot of. Oh, my bad. Yep, there it is. Variables. Huh. Did I? Where is my error? Array must be in positive integers. What? Let me double check. 0. Oh, my bad. Yep. Again, careful. Matlab starts with 1, not 0. There we go. Yeah. I always struggle with Matlab because of this. Okay. Matlab starts indexing in 1, not in 0. I don't know why. Like, I don't know. The syntax is just not there. It could be improved. They're starting to count in 1, not in 0. I don't know. If you want to get fancy, yeah, like MathWorks, what happened? Cool. Control Enter. There we go. Cool. We can see that we have 26,000 rows, okay? Because we're going to get rid of the rows, okay? We cannot get rid of just the cell because that doesn't make sense. We get rid of the rows. So 26,000 rows of, let's call it malformed data. Let's just check if that's, or how much data we actually have. So you can see here, there's a number. It says 88875, okay, which is 800, what is it? 88,875 times 12, which is actually 11, which is the number of rows, no, the number of columns, okay? So we have in total 977 pieces of data, or cells, okay? We have 88,000 rows, and we're getting rid of 26,000. Not the best data set in the world. Let's just play with it, but not take it seriously, okay? Careful there, because if not, then you can run into some serious issues, okay? Cool, get rid of this. Nice. Okay, so let's section this, because I don't want it to run forever. There we go. Cool. So let's just get, let's do it here. Get rid of the missing data. Cool. So UFO dataset equals RM for remove missing, and as easy as that. Cool. Done. No more missings. Okay. Cool. If I do it again, there we go. You can see now we scroll down. We don't have any missings. See here, we had one in the second one. Now we don't have it, but see the actual value changed. We actually got rid of the first three, or the second one and third one, and now the fourth one is the second one. See Etna and Etna. See that? Sad, but you cannot risk having malformed data in your projects. Okay, cool, awesome. So I always say this, always say this. Actually, I'm going to throw a little bit Tammy under the bus. I don't know if you're connected. What was the thing that I say when you have data? You have to what? You have to have it prettified, but you have to what? It starts with V. So I'm going to give it like 30 seconds. I don't know if Tammy is still connected. Yes, no, it starts with V. You have to what? Nope, don't remember. It's fine, it's fine. You have to visualize your data. Okay, so always visualize your data. If not, you can kind of understand how it works, but you don't see it. Okay, now you had it. I knew you had it. Cool. Okay, so let's see it. Let's see how that looks. Okay, cool. So some of these cannot be plotted because they're strings. You cannot plot strings. Okay, so you have to make something called a categorical object, which is something that we can count. Okay, so we can do countries equals categorical of UFO dataset that country. Okay, why that country? Because we have the, here it is, dot country. Okay, cool, awesome. So same thing for shapes. It's categorical in UFO dataset dot shape. There we go. Cool. Again, shape is, you can find it here. Here it is. Okay, cool. Awesome. So nice. Now that we have a categorical, okay, let's just write here so we can know what's happening. Make it categorical. There we go. Now, convert to numeric codes for scatter. Okay, remember scatter is like a lot of points. Okay, that's what we want to see in this case. X equals double. Let's do double. Countries. Okay, and y equals double shapes. Okay, cool. Now we're doing it from a categorical. We're making them a double. Okay, so that we can plot them. Okay, we have to do something that's fix the axis with categorical labels. Label. Come on, label. There we go. X sticks. Okay, we do 1 all the way up to null. Okay. Now we're doing what you're doing is we're creating the length of the x-axis and the length of the y-axis. Okay, so 1 to null of categories in countries. Okay, same thing for what x, in this case x6 labels. Categories in countries. What are we doing? Bear with me. Bear with me 2 more seconds and it'll make sense. Okay, cool. Y-text now. Okay, let's see if we have any comments. Nope. Y-text 1 to null. Categories of shapes. Okay, remember that's the Y. Okay, and the excess countries. Okay, and Y-text labels. It's Y-text. Yep, Y-text labels. Categories. What's wrong with my? There we go. What's wrong with my typing today? It's horrible. Even with my keyboard, it was horrible. I don't know. And I didn't game today. I usually game. I didn't game, and damn, it's not good. Cool. Okay. Now, X label. Country. Okay, that's the labels of the X and Y label. It's shape. There we go. And we can do one last thing, which is title. Always prettify your data. Please, 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 please. Don't plot anything that doesn't look good, because if not, you'll go back to it and you'll say, I don't know what I'm looking at. Okay, cool, nice. So if you ask yourself, are you like this in real life? Sadly, I am. Okay, UFO. Ask my family. Sightings. You don't have to. You can ask Amanda. Like, she's the head of the admissions team in the fellowship, part of MLH. Yeah, she can agree that I'm like this 24/7. Like whenever we meet, she's like, "Hello," and I'm like, "Hello, how are you?" Cool. I'm my bad. I'm sorry. Just I don't know. I like being funny. or trying to be. Country versus shape. There we go. 3, 2, 1. Let's see how this looks like. Do we have an error? Please give me an error. I know we have an error. Yes. Okay. Xstick labels. Xstick is Xstick, I think. Yep. Cool. I knew it. It always happens. Okay. Now, what's wrong? Should we see this? Should I get rid of these? I'm not sure. Interesting. Australia, country, shape. Should I be looking at this? Wait a minute. I think I shouldn't. Let me just run this. This is my cheat sheet, just in case this happens. That's why I have a cheat sheet. I think it should happen. I think it's the way of not doing it. Was that my intention? Nope, it wasn't. Okay, let's get back here and see what we did. Okay, any comments? Yeah, happens all the time. Okay, cool. Let's see. Let me just read it real quick. Countries, categorical, UFO dataset country, yes. Categorical, yes. Doubles, there we go. 1 to normal categories. What is categories though? Do I have something called categories? Do I? Countries, categories, countries. What is categories? 1, 4. No, I think it's a function. Yeah, should be a function. Countries, categories. What? Darn it. Where's the error? Categories, countries, 1 to normal. Yeah, that should be fine. 1 to normal, that should be fine. In shapes. Yep. Shapes. Where's my error? Should I do this like this? Nope, doesn't work. Well, that's interesting. I'll do the old copy paste because if not, we'll just run out of time. But yeah, I have an error just there. I don't know what it is. Let's just see AV. Ooh, that's not good. If you do Control A, you get the whole thing. It seems. Okay, can I do this? I'm not sure. Oh, yeah. I just forgot to say scatter. Okay, now let's do it. Let's do it in our code. We can do scatter. X, Y. It happens all the time. Okay. Filled. Yeah, I know. Yeah, there you go. That should work. Yeah, that's it. Okay, cool. I don't know why this is there. I should get rid of it. Yeah, it's fine. Cool. Okay, so you can see this is the scatter. Doesn't make any sense, right? Like we're trying to plot something that doesn't make any sense against each other. And if you remember my last stream, I'll mention it just in case you were not here. There's a correlation factor between data. There's a formula to it, but without diving into the formula, there's nothing that country in the shape of the UFO mathematically has in common. There's nothing. Okay, it's not that UFO sightings in the US are only, I don't know, lights, and in Mexico are cylinders. Okay, there's nothing mathematically that we can prove that happens. Okay, so mathematically, nothing is happening there, and we are not counting. Okay, so you can see it says UFO sightings. We have a sphere. Okay, in Canada. In Great Britain, I guess this is Great Britain. We have a circle, for example. We only have a light, and that I think it's a triangle. Mathematically, it's not that you can relate those two. It's just two strings, right? It could be any words. It could be cylinder in Mexico, or I don't know, fireball in Brazil, or cone in Abu Dhabi. I'm not sure. Whatever you want, it doesn't make sense mathematically. Okay, so this is not the correct way to plot these types of data. Okay, cool. Now, we can plot something called a histogram. Okay, so let's plot a histogram. Histogram. Okay, easy. histogram. Okay, categorical. My bad. Again, my typing is just not there today. UFO dataset. The shape. Okay, what will this output? X label is UFO shape. You can do it without the thingy. There we go. Y label. It's number of sightings. Okay, so we can see that this will count each shape. Okay, and then always, please, again, titles. Okay, title. I know it takes time. It takes a couple of seconds. It makes it better. Okay, please, 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 whenever you plot your data, even if it's for you, not for your teacher, not for your boss, I don't know, it's for you. Make it beautiful. Okay. Distribution of UFO shapes. Because why not? Whoever just connected to the stream, they're like, what? UFO, Matlab, what's going on? There we go. Ooh, that looks better. Okay, that looks way better. You can see that each one of these has, I think this one is light. The one that has lights or the sighting that are just lights are the most common, if you can see. I think it's 15,000-ish, okay? The one that are least common, for example, crescent has nearly 0. Changed, which I don't know what it is. A hexagon are nearly 0, okay? If they're there, it means at least there's 1, okay? But you can see from the plot that they're not really relevant, okay? Piece of advice. Whenever you see non-relevant data, best thing that you can do, get rid of it. Okay, so for example, I don't care about the changed, about crescent, about flares, about pyramid, because in the thousands, you have at least, I think it was like 80, from 88 minus 26, I think it was like 50,000 sightings, let's call them. You probably got like 15 pyramids, for example. Not relevant at all. It doesn't make any sense if you keep it or leave it. It's nothing. It's like 0.8%. It's nothing. Okay, you can get rid of it. It makes your model less complicated. Okay, if you're working with neural network, it makes it look at less complex data. Okay. Piece of advice: if you wanna keep the data, it's fine. I don't think it adds. It just uses more time and complexity. Okay, cool, awesome. So that's for histogram. Okay, what can we do as well? We can do a heat map. Okay, if you remember from my previous stream, heat map is like a square that the diagonal meets itself. Okay, so for example, let's say that you have years of experience and I don't know, salary, okay, from the thousands, okay, to 1,000, 2,000. So you can see that, for example, 10 years of experience meets $1,000 an hour. Okay, I don't know, that's probably the rate, hopefully. I don't know, stuff like that. Okay, so you can plot different kinds of data, and the diagonal is your, let's say that the coincidence of each and every single one of them, and from there you can look at it. Okay, let's just look at it. Why not? Let's just plot something like that. TBL equals careful, it's groups. Group summary. Okay. It's UFO dataset. Okay. No, that's not. It's not dot. It's this. We should get the country, and let's should get the shape. There we go. Cool. Now, do you have comments? I'm not sure. I don't think so. Cool. Okay. Now, heat map. Now, again, I didn't explain this. I just write code without explaining. Okay, we're basically summarizing each group of countries and shapes. Okay, we'll see it now. Heat map TBL, which is that summary. Okay, we want country. We want shape. We also want color with capital C, color variable. And we want group count. Okay, this will all make sense in a second. Okay, title again. Please always titles. UFO, or maybe like this, UFO sightings by country. Oh, and shape. Let's take a look at that. Oh, great, awesome. Give me errors. Group summary. Group summary UFO dataset, country shape. I think it has to be with the usuals. I think I don't remember the difference between those two. Yeah. Yeah. Okay. I don't remember what was the difference between the usual like the characters and the strings. But yeah, again, MATLAB being MATLAB. Okay. Cool. Now this is a heat map. It doesn't make sense. Okay, again, it doesn't make sense. Now, Bully, you're just teaching us how to do stuff without making it sense. Yeah. Sometimes people want to plot data that doesn't make sense, and they just discard data sets because it doesn't make sense. You're just plotting it wrong. Okay? Usually data sets make sense. Usually. Not like Tammy, you remember, right? Where's Tammy? There you go. Tammy, you remember. Movies data set didn't make sense, right? But usually makes sense. Okay. Cool. Awesome. That's a heat map. Okay. You can see the heat map is basically like the name comes from like hot or like warmth. Okay. The more repetitions we have, the warmer it gets. Okay. So you can see this bluish is the US, and we have a lot of lights in the US, and that makes sense. You can see lights in the US. Okay, cool, awesome, nice. So a lot of NANDs. Okay, just careful there. Again, it doesn't mean that your data set doesn't make sense. It's that you're just not plotting it right. Okay, cool, awesome. Last but not least, we have actually, yeah, cool, awesome. Now I forgot about this. I should have done this before. You can find the relationship between two thingies, and MATLAB will kind of force it for us in this case because it's not a number, it's a string, but you can do it like this: correlation coefficient. Okay, UFO dataset dot. Okay, we can do it for strings. It won't make sense. Okay, but we can relate the shapes. And we have another interesting here that it says duration in seconds. Okay, so let's see if there is a relationship between the shape and the duration of the sighting. Okay, let's see if mathematically we can find something interesting there. Okay, if you do this and it's not correlated, you're not looking at the correct data. Okay, it just doesn't make sense. Okay, cool. So sip of sparkling water that, again, I don't know, people like it. Do you like sparkling water? Put it in the chat if you like sparkling water or not. I don't. Why you drink it? I didn't have anything else. Like a bottle of water, yeah, probably. I probably have like sparkling water with lemon, but it was like a 4-liter bottle. I'm not going to finish that, so I'll just, yeah, that's why. Cool, okay. UFO dataset dot duration seconds underscore UFO dataset the shape. There we go. So let's see if there's a relationship between those two. Oh, great. What? Core coef UFO dataset duration seconds. Is it correct? Unmatched parameter name of the pair. UFO dataset the shape. Am I missing something? Is there something that I'm not looking at correctly? Not this. Not this. Should be this one. What? Oh yeah. Oh yeah, yeah, yeah. Okay, got it. Yeah, I remember. Okay, cool. Basically, what it says is, hey, shape is not a number. Shape is shape. Okay. Okay. Just to be clear. Okay. What's the formula? I think we had it before. A correlation formula. There we go. Let me see if I can find something here. Correlation. Let's see it real quick. Yeah, here it is. Copy this, paste it here. Come on, text. Can I do this? Yeah, there you go. Cool. Okay, that's your formula. Okay, so you tell me. Okay, you tell me, because I wouldn't be able to. Where would we fit shape? We cannot fit shape there, right? It's not a number. It's not. I know. This looks like a word. It doesn't make sense if you fit shape there, right? Tammy says you like sparkling water with mint, but not absolute favorite. What's my favorite drink? Have you ever heard of, I don't know if this is a thing in the US, Yakult? Do you know what Yakult is? Should I explain what okay. Notes. Does my grandpa has any? Yeah, wait a minute. Okay, let's see. Piece of pen, and then right here, Yakult. Okay, I will show you what the Yakult is at the end. Okay, but yeah, that bubble tea of that flavor, oof, delicious. Okay, delicious. Cool, awesome. So this is basically says, hey, your correlation is nothing. We cannot correlate your data. In this case, if you want to do linear regression with this, good luck. Not to you, to the computer, because it won't find anything related. Okay. Cool. We are done with UFOs. Okay. Cool. Now, nice. Next thing, please download, if you're following. Okay. Please download this thing over here. Okay. I downloaded it before. It says, yes, the yogurt drink. Is it a yogurt drink? I know it comes from the milk. I know what they make cheese, like the water that's left behind. That's what they use as a base. I'm not sure if it's a yogurt drink, but yeah, you're kind of there. But that thing, bubble tea of that flavor, oof, delicious. Okay, delicious. Cool. Okay, so downloading that dataset gives me salary dataset. Okay, cool. Now let's open salary dataset. Okay, just don't forget to do the unzip. Okay, I already did it, so I won't do it. But yeah, unzip, and then should be archive 1 if you are following. Okay, cool. So let's read the dataset. There we go. Awesome. So salary dataset. Oh, my bad. Dataset. I'm hungry. I'm really hungry. Read matrix or table? Table. Cool. If you read matrix, Matlab is going to try to read all the numbers. Won't work. Okay. Salary dataset. There we go. Autocomplete for us. Thank you. I hate autocomplete. Just in this case, I'll just go with it. Okay. Let's look at it. Okay. Cool. We have var 1, years of experience in salary. Okay. var 1, for whoever doesn't know, some of the datasets contain this first column, which is the index column. Okay. For Python, for Pandas, for Matlab, it doesn't take into account explicitly, it doesn't know that this first column is the index. So it takes it as a data column, if you will. Okay, we have to get rid of it. It's just not the way. And you can see it starts with 0 as it should. MathWorks, please do your job. It should start with 1. I'm sorry, with 0, not with 1. Okay, MathWorks mean MathWorks. Please sponsor me. But yeah, cool. Okay, so get rid of that now. Okay, so we'll get rid of it right here. Remember, salary data set equals remove vars. Okay, from salary dataset, I want to get rid of var1. Yep, 3, 2, 1. Oh, again, my bad. It's this thing. I don't know why. Okay, cool. We got rid of it. Okay, so far so good. Nice. Okay, let's just get rid of this. Cool. Okay, now we saw the correlation before. It's a horrible error. It says, I don't know what you're talking about. This doesn't make sense to me. It won't make sense to anyone else. Now, we'll see this data, but we see that we have two numbers, years of experience and salary. We can see that years of experience going up and the salary doing the same. Ideally, that's how it should be. For 3 years of experience, you get a $56,000 salary. I'm not sure if that's the correct thing or accurate, so you tell me. But yeah, that's what we got for the data set. Let's check if it actually makes sense mathematically, okay? So we can see core coef, which is a correlation coefficient of what? Salary dataset, okay? That what? Years experience against salary dataset dot salary, okay? Ready? 3, 2, 1. Oh, my bad. 3, 2, 1. Ooh, we got a heat map. Okay, so we can actually plot this. I won't plot it. It takes time. We have 40 minutes. You can see there's a coefficient of 97%. Can you see this? Is that seeable? Yes. 97%. The closer from 1 or -1 is 100% of correlation. And 0 is 0. Okay, so 0 is nothing, and you go from there. Okay, you can either get -1 or 1. Okay, cool. We got a nearly 1. Great, 10 out of 10. If you get a 1, it means that your data is probably the same. Okay, careful with the ones. Okay, cool, awesome. So, there we go. Nice. Okay. What else? Oh, yeah. Okay. So again, you can understand your data, but I want you to see your data. Always see your data. Okay. Get rid of this, and let's do scatter. Okay. Why scatter? Because we know that it's x and y values. It's not an amount of things. It's different values with different that should go up. Okay. That should be a scatter. Okay. So scatter what? Salary dataset. The years of experience, that's your X, okay? Years of experience. X value, not your X partner, okay, careful. Cool, and then salary dataset, dot, you probably would say, why do you say that? That's not even funny. I know, I don't know. I'm a random person, I just say random things. Cool, X label. Yeah, yeah, that's me in real life, okay? Years of experience, okay? Y label. Again, please label your data. Salary, okay? That should be a string. Oh, come on. Salary, it doesn't do you a favor there. Title is experience versus salary. 3, 2, 1. Let's take a look at it. Oh, that looks beautiful. See, that makes sense, right? This doesn't. This scatter doesn't make sense. This is a good scatter. Okay, actually, for this data, we can see that the histogram makes sense. And this one, we can create a histogram. Matlab will say, I don't know what to do. I'm sorry. Okay, but the scatter makes sense. And you can see it actually makes sense. Okay, cool. Now, you can plot different things. You can plot a scatter, or you can plot something called a time series. Okay, let's take a look at time series. So plot, okay, salary data sets, that years experience, and then salary data set, that salary. Okay, so far so good. Do you have comments? I'm not sure. We don't. Cool. Nice. So we can, so time series, as the name refers, it's not a static series. It's a moving series. Okay, it means it's not just drawing a line. It'll draw a line doing something. Let's draw a line doing the mean. Okay, so each time it moves, it'll output the mean. Okay, so you won't see that it'll touch every single dot. It'll go through the mean. Okay, cool. Smooth salary equals MV mean. Okay, and then we get the salary. Oh my bad. Salary data set. That's salary 5. Okay, cool. Which is, this is a fine 5-point moving mean. Okay, cool. I'll call semicolon because if not, I'll see everything. Plot salary data set. What's wrong? Salary data set years and experience. There we go. And then salary data set. That salary with O's. Oh my bad. O's. Okay, like this. And then you can do something in Matlab which is cool. Hold on. It means I want you to hold on your plotted table. Okay, your plot, hold it on. I want to draw over it more. Okay, that's what you can do. Okay, that's what hold on means. Okay, cool. Now we can plot again salary data set. That's what you'll hear when you go to sleep. Salary data set, the year's experience. And then smooth it. Salary. This is going to be a line, okay? Line width of 2. Okay? And then again, please labels, please prettify your data. X label, label, there we go. Experience in years. Y label salary. Careful, huh? Careful with the salary. There we go. Yeah, that's me. Legend. Okay, legend means I want you to tell me which line and which dot is what. Because when you have a lot of plots in the same plot, it's kind of difficult to see what's what. So you can do legend, and then instead of legend, you can do, let's do scatter. Okay, that's the first one. The second one, it's time series. And then the third one is moving average. Okay, cool. And please, title. Okay, salary versus experience with moving average. 3, 2, 1. Errors. Yes. What? MV. Oh, it's MOV. My bad. It's MOV mean, no MV mean. Okay. Cool. There we go. Smooth it salary. It's smooth salary. My bad. There we go. That should be a 3, 2, 1. Ooh, cool. Okay, you can see here. Okay, we have scatter, which is the blue ones, and the moving average. Oh, actually, no. The scatter should be here. Let's see what's happening. Okay, yeah. I think it took scatter from this one. We probably should do. No, we shouldn't. I was going to do a CLC, but that doesn't. Yeah. Let me think real quick, because we're getting 3 different plots, but not. Should I do hold on probably here? Maybe this is the first plot, second plot, yeah. Probably there. Ah, yeah, there you go, cool. Nice, so we have the scatter, which is the blue ones. The time series is the red line, you can see it's moving, okay? And the moving average is this line over here, okay? You can see, I think it's actually, no, yeah. Did we do it correctly? Smooth salary is the third. It should. Yeah, I think these two are incorrect. This should be like this, but it doesn't make sense. Let me just think about it. There we go. Yeah, this is acting weird. Scatter, moving average. That's weird. Shouldn't do this. Salary, hold on. If I get rid of the spaces, I don't think it will do anything. It just changes the color. That's dumb. Because time series should be your blue line. No, time series should be this line that touches every single dot. The scatter is the green dot, and the blue line is the moving average. But I don't know why it's not doing it. I think it happened to me that last time, and I didn't correct it, did I? Nope, I actually have data here. Nope, okay, yeah, cool. My bad. I'm not sure how we correct this. Let's see. Legend scatter. The scatter is the first one, right? Moving average. It's the second one. It should be this one. It doesn't make sense, okay? I'm sorry, I don't know how to correct this for now. But you can see the line that doesn't touch every single dot is a moving average because it's averaging every single one of the dots. If you see, it touches the first one, but not the second one because it's now doing means, okay? Cool. The time series is the one that touches all of the dots, but instead of just dots, it connects all of them. And your scatter is your usual scatter like this, okay? Cool, nice. Let's kind of forget that this doesn't work or I did it wrong. So yeah, cool. Okay. We can do some linear regression. Do we have time? What else can I do? Oof. I think I'm going to skip linear regression just because we did it earlier. Yeah, I'll go with probability. Okay, cool. So probability, and distribution. Okay, cool. Different data set, okay? The third data set is this one right here. That's the third one that we're going to use. Just in case you're following, I'll send it here. Awesome, a little bit of water. Tammy, you drink it with mint? That's not bad. It doesn't sound bad. Probably mint and some sugar might do the trick. Cool. Okay, now we have to read, which one was it? Let me just copy this. So it's a Spotify dataset, okay? Full of songs. Let's take a look at it. You see the song name, song popularity, song duration, acousticness, danceability, energy, instrumentalness, key, liveness, loudness, audio mode, speeches, and more data, okay? Numeric data, things that we can work with easily, that's good, okay? Cool, so let's not read it a lot. You can see that this one doesn't have the first index column. Some data sets contain it, some don't. It's up to the author, okay? Cool. So, what do you think we can do here? Can we do a scatter? Can we scatter this? Does it make sense to scatter this full of numbers? Or should we probably do a heat map? Or maybe how do you call this? A histogram? So I think I would go with a histogram and see how it looks. Okay, so let's do a histogram of the song's duration. the ones that are 2 to 5 minutes. Okay, cool. So we can do histogram, pretty straightforward. Spot the dataset. Okay, the song duration, I think it's in milliseconds, divided over 60,000. There we go. Why do we divide by 60,000? Because we're taking account as milliseconds. If you want to take it in account as seconds, no, as minutes, my bad, as minutes, then you don't, you divide it over 60,000, okay? Cool. Now, 50 here and normalization, and then we add PDF. I think this has to be PDF like this. We normalize PDF. What was PDF? Cool. Okay, I'll take a look at it in a second, but let me just get rid of this comma that's not there. Cool. Awesome. And now, please, X label again. Should be song duration 60 seconds. Okay. Y label. What? There we go. Probability density. There we go. And last but not least, please, please, please never forget the title. Distribution of song durations. 3 to 1. Let's take a look at it. Great. Song duration. Cool. What? Oh. What? Oh, wait a minute. I think I have to do hold off. There we go. Yep. And then, yeah. Okay. Careful with hold on, because it holds on to your plot. If you don't hold it off, then it just gets confused. Okay. That's Matlab. Cool. We can see the distribution of the songs, and you can see that in between 2 to 5 minutes, probably something like right here all the way to 5, we can find most of the songs. Okay, so I don't know, probably Eminem songs, which are pretty long, are usually right here. Okay, cool, nice. So heat map or correlation matrix maybe. Should we try a heat map? I don't have it in my cheat sheet. Should we? I don't know. Let me see. What do I have else to do? Wait a minute. We can do a Monte Carlo simulation. 628. Okay, let's do it, but at the end, Tammy. I don't know if we'll be able to do it. But yeah, let's try it at the end. Okay, cool, awesome. So there's something called Monte Carlo. Let's add a text here so it looks good. Monte Carlo simulation. Okay, this simulation it's a method that uses random sampling to approximate approximate answers to problems that are okay. By the way, you can find this MATLAB in like the cheat sheet, the good cheat sheet. You can find it on GitHub. Okay, my GitHub's name is Bully1601. Okay. Oh, well, Monte Carlo would be pretty cool. Yeah, let's just simulate quickly like the probability of finding a song between, I think it's between 2 to 5 minutes. Okay, cool, nice. So problems that, let's just explain what Monte Carlo is. Cool. Too complex to solve, or don't have a need for new luck. There we go. That's why you use Monte Carlo simulation. Okay, cool. So 30 minutes to go, 20-ish minutes to go. Let's see. First of all, let's take the song's duration in minutes. There you go. So same duration equals rand sample, and then let me zoom in because I don't. Spotty dataset. There we go. That song good duration milliseconds over 60,000. Okay. Let's do 10,000 of these, and then can't see it on my iPad. I didn't take the correct picture. It says true. Okay. It just says true. Cool. Now, what is this? Okay, let's take a look at it. Rand sample. Why do I have to always get the weird errors? Organized value of true. Did I get it wrong? Oh, my bad. I'm doing it like Python. Ooh, my bad. Yep. You just get used to it. Okay, cool. Now, we get the simulated durations, and we get 10,000 simulated durations. Okay, cool. From there, let's reshape into columns of 5 songs each. Okay, it means let's group them into 5 songs each. Okay, cool. Okay, so playlist equals sum of reshape sim durations 5 and into nothingness. Okay, bear with me. And then let's ask ourselves, what is the probability that a random 5-song playlist lasts more than 20 minutes? Okay, so that's what we're trying to do. We converted every song's duration, because it was in milliseconds, all the way up to seconds here, okay, to 60,000. We got a sample of a 10,000. And then we reshaped it into, let's call it like, we grouped them into groups of 5. Okay, cool. Let me just get rid of this one. Sorry, Tammy. There you go. Cool. Now, it's easy. P equals, the probability equals the mean of the playlist being bigger than 20. Let's see that. The probability of a random 5-song playlist to last more than 20 is 17%. Okay, why is that? If you think about it, okay, a usual song lasts 2.5 minutes. Okay, times 5, 10, like 12.5 minutes for you to get a 5 random song that lasts 20 minutes or more. We can actually up it, there we go. You can do that. My bad, I'm just arrowing it. This is too much R. It's there we go. Cool. Okay, yeah. If it lasts 20 minutes or more, it's 17% sharp. Yeah, it makes sense, because if you just get Eminem songs, then probably, but yeah. Oh, I don't know, if we have like in the data set something like, I don't know, classical music like Vivaldi or something, it lasts like 5 minutes each. If you get like 5 songs with 5 Vivaldis, then yeah. But that's how the probability works. Okay, so that's how you can simulate basically data inside of your data and ask for the probability. Okay, you say, hey, I'm going to sample, I'm going to reshape, and then I'm going to ask myself, hey, what's the mean of the playlist being bigger than 20? Okay, what about the usual? We said 12.5. I think it's 99%. Okay, because at least if you have 2 songs that last 2.5 minutes, and then 3 songs that last 2 minutes, you got it. Okay, cool. I think we just missed something before. I thought I wouldn't have time, but I do. So let's go back here. Cool. I think I can remove this hold off for now. Cool. We could do something else. One last thing, which is linear regression. Okay, let's do it real quick. So P equals polyfit. Okay, poly for a shape. Okay, so we fit the poly shape. Salary data set did years experience, and then salary data set dot salary. You get 1 here, okay, which is the degree of the polynomial fit. One line, a straight line, like it's just 1 degree of your polynomial, okay? Remember the equation of the line is, let's write it down here. It's y equals mx plus b. Okay, you don't see any complexity in this equation. It's just 1. So it's a simple line. Okay, cool. So that's why our complexity in this case is 1. If not, it will be a polynomial fit. Okay, it's a little bit more complex, but it should fit more. But it's used more for classification of clusters. Okay, cool, awesome. So let's do this. And now the regressive line equals polyval of P salary dataset that years experience. Okay, why is this? We have to fit this fit. This is your y value. Okay, so if you do polyfit, it means I'll do linear regression with your x value, but I'm just giving you a y value. The x value doesn't change at all. Okay, it just helps you map between your years of experience and your salary. Okay, my voice can't keep up. Let's do it. Let's do it. Okay, cool. So now we can plot salary dataset that years experience. Again, that's your x. Okay, now the y is regression line. Okay, we wanted green dotted. That's what that means. Okay, G for green and double dash for like dotted line. Okay, and then line width should be 2. Ready? 3, 2, 1. Great. I love errors. Careful. It's not polyval. It's ployval. Yeah. Polyval. There we go. Ah, good. Good, but it doesn't. Oh, come on. Let's do this. Let's do it here because we did the hold off. So we do hold on, and then we do this. 3, 2, 1. Ooh, we have linear regression. See that? So now, and let's hold off here just in case. Hold off, okay? So we have experience versus salary, years of experience in your x value, y value is your salary, and you have a line. For those who weren't in my linear regression stream, shame. No, I'm kidding, okay? I'm kidding. It means this line will try to predict the means of all of the dots for it to predict new values. So if I had experience of 20 years, for example, I would be right here. I would say, hey, how much my salary based on the data would be. And that's how you can predict, okay, based on the line. So the line would probably be like right here, okay? Cool. That's it. Awesome. I think my voice cannot keep up. Nice. I think that we covered the whole thing, right? Let me just see. I think we did. Any comments? Yes, there's Tammy. Hey, Tammy. There we go. Oh, wait a minute. I promised Tammy something. What was it? Heat map? Can we do a heat map on these? I think we can. Okay. Let's see how a heat map is done. So where's the heat map? It's right here. Okay. By the way, if you double click on your plot, it'll take you to your code. Okay. Cool. So we have to get groups between, in this case, country and shape. But let's do that between, let's copy the code, okay? Let's just copy this code. Did we hold off here? Yes, we did. Okay, cool. So let's do the same thing, but instead of UFO datasets is spotty dataset. There we go. It's not country. So let's see. Cool. Let's see if we can do something interesting here. So a heat map between maybe song popularity and I think duration millisecond is going to be really vague. Do we have something more? Tempo is going to be really difficult. I'm trying to find like numbers that are not very different than each other. Because if not, the heat map will be just horribly big. We can find popularity against danceability. Can we do that? Popularity over danceability. Should be, yes, okay. Okay, heat map between popularity and danceability. Okay, and instead of UFO, let's change the title to songs that are popular and dance. Can we do that? Yeah, no, okay. What's the error from invalid grouping valid? Okay. Okay, T blah 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 by general group parts blah blah groups by group T. Interesting. Popularity. Did I write it correctly? I think I did. Oh, it's song popularity. My bad. Song popularity. Heat map. Oh, come on. Heat map by this. My bad. My bad. This should work. It doesn't work. True. My bad. But turn hold off. Didn't I? Didn't I do it? What? There? That's what you want? What? Oh yeah, okay, yeah. That's what we're running into. So Tammy, your question was, can we do that's a nice correlation? Awesome. Yeah, that's the one that I could find. The thing is, it's too much. Okay, so for every song popularity, let's say score, okay, we can have numbers from 0 to 100. Okay, thank God, non-floating. Okay, if not, then we would have infinite numbers. But in this case, we have finite numbers from 0 to 100. The bad thing is, danceability is very much infinite. Okay, you can find infinite numbers here. And they're rounded to 4 decimals. So it's very difficult. So you see, you have 100 numbers here times probably 10, 20, 30,000 numbers here. See, so we can definitely see it. And everything is in N because it's just non-plottable. Okay. Now you said something interesting. I think you said correlation matrix. I think we can do that, but I'm not sure how to do the correlation matrix. Let's just Google it real quick. correlation matrix Matlab. There we go. Never done a correlation matrix before. Oh, it's core plot. Okay. Yep, let's see it. Oh, cool. We can do the same thing. So instead of heat map, we can do core plot. Does that work that way? Nope. Using hold with heat map is not supported. I get it. I get it. Oh, come on. I need a toolbox. No, forget it. No, I need a toolbox. I have to download it. It takes time now. Okay, cool. But you follow this. Should be the same code, but instead of doing that, you should follow that, okay? I'll just give you the code. Should I? No, I'll just leave hold off there. Cool. And use this, okay? That should be your code, okay? If you follow that first link, it should give you the correlation matrix. I have to install the econometrics toolbox, but it takes time. Okay, I have to, like, MATLAB has to restart. It's a mess when you download this. Okay, cool. Okay, awesome. Let's see. Cool. I think that's it. Nice. Any interesting questions? Anything that you'd like to share with me? Awesome. Thanks, Tammy. Yeah, sparkling water, 0 out of 10. Cool, awesome. So one more thing, okay? Let me share with you. Where is it? I have it here. Copy link address. Could you please give me feedback, okay? I know that I hope that you had fun. Okay, I hope that you had fun. I want to get better as a streamer, okay? So let's just follow that link and see how it looks like. So let me unshare. Share. I should open it first. Control V. There we go. Now I should be sharing. Screen share. There you go. This is the one. Okay. Cool. So you click on continue. And instead of predicting with linear regression, which was my previous stream, you change it to probably the keyword should be Matlab. Cool. Click on here, and then, for example, how would you rate the contents of statistics with Matlab? Okay, it was horrible, 1, or it was great, 10. Okay, I don't take it personal. If you loved it, oh my, what? Didn't add it to the stage. My bad, my bad. Cool. Okay, again, let's go back. To get this, we're gonna continue. You click on statistics with Matlab. Okay, with this. And then if you really didn't like it, am I sharing this? Yes. If you didn't like it, 1. If you liked it, 10. Okay. Give me feedback. Okay. Cool. Awesome. Hey, thank you, Karime. And thanks, Tammy. Awesome. Cool. Okay. So I think that should be it for me. Thank you for joining. I think I'm the last stream of the day. I'm not sure. Can I check it real quick? Yes, I am. Tomorrow you have with Cecilia and Siddharth. Today in Global Hack Week, weekday 5. So it's at noon tomorrow. Okay, noon EST. Okay, so yeah. Thank you for being here. Thank you for watching. I hope you had fun. If anything, just let me know on Discord. Ping me on Discord. I think it's Bully from MLH, and yep, I can answer questions there. And you can find everything in my GitHub, just in case. My GitHub is this one right here. Awesome. Thank you for joining, and I'll be seeing you next Global Hack Week. I won't be streaming this Hack Week anymore. But yeah, I'll be happy to see you next time. And yeah, thank you for joining, and I'll be seeing you around. Bye-bye.